projects. In this video, we are going to see Twitter sentiment analysis of public opinion on COVID-19 vaccines. Introduction. Twitter has become a dynamic platform for expressing a range of public sentiments in the ever-evolving discussion surrounding COVID-19 vaccines. This sentiment analysis project analyzes a sizable collection of tweets to determine the prevailing attitudes, worries, and opinions about COVID-19 vaccines. We aim to identify insightful information that clarifies the narrative surrounding vaccinations around the world by utilizing the power of natural language processing. Objective of the project. This project uses Twitter data to analyze public sentiment toward the COVID-19 vaccines using the random forest machine learning algorithm. It aims to forecast sentiments, positive, negative, or neutral, from tweets, providing perceptions into the views of the general public. The goal of the project includes pre-processing of the dataset, feature extraction using TF-IDF, model training, sentiment prediction, and creation of comparison graphs. It makes it easier to understand how the public feels about COVID-19 and its vaccines by identifying the prevailing attitudes. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload COVID-19 tweets dataset. Using this module, we will upload tweets dataset to application. The second module is data preprocessing and transformation. After gathering the tweets, we preprocess them by removing stop words and special symbols. This ensures that only meaningful words remain, reducing noise in the data. The third module is data visualization and features extraction. Through data visualization, we create graphs to visualize the distribution of sentiments, favorable or against vaccines, in the dataset. This provides a clear overview of public opinions. The TF-IDF vectorizer converts the textual data into a numeric form, preserving the semantic meaning of words and enabling the training of the random forest model. Sentiments will be taken as class label. TF-IDF term frequency inverse document frequency will find average frequency of each word and then replace that word with its frequency to form a numeric vector. The fourth module is train random forest on dataset. The TF-IDF vectors enriched with sentiment labels serve as input to the random forest algorithm. This algorithm builds a predictive model based on the features extracted from the dataset. Random forest constructs an ensemble of decision trees, enhancing prediction accuracy and robustness. The next module is sentiment prediction on test data. We utilize the trained random forest model to predict sentiments of new unseen test data. This process involves applying the TF-IDF vectorization to the test tweets and using the model to classify their sentiments as positive, negative, or neutral. The last module is sentiment comparison graph. By plotting a comparison graph, we visually present the distribution of sentiments positive, negative, neutral among people's opinions on vaccines. This graph offers an intuitive representation of the prevalence of different sentiments within the dataset. Execution of the project. To execute this project, first we need to open the code folder. This is the dataset folder in which I have Twitter sentiment analysis dataset. So I am opening this dataset. So in this dataset, we have all tweets details such as tweet ID, user ID, tweet text, and many more, and we will use this dataset to train random forest algorithm. Close this, and this is the test tweets dataset. So it containing only tweets but no information of sentiments, and when we apply random forest on this dataset, then we will get sentiment label as positive, negative, or neutral. Close this, and this is the Python main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created this Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload COVID-19 Tweets Dataset button. A dialog box opens, select the dataset and click on Open. It confirms that the dataset is loaded, and these are the top 5 rows of the data, and there are 16 columns in the data. Now click on Data Preprocessing and Transformation button to read dataset and to remove stop words and special words. So we can see all the stop words and special words are removed. Now click on Data Visualization and Features Extraction button to visualize tweets and then extract features from tweets as TF-IDF numeric vector. So in this pie chart, we can see percentage of received against and willing to take vaccination according to the tweets. Close this graph, and in the text area we can see total tweets found, total positive tweets found, total negative tweets found, and tweets about willing to take vaccination count. And we can see numeric vector where all words become column names, and rows, and in the rows we can see TF-IDF frequency of the words. Now click on Train Random Forest on Dataset button. So in this confusion matrix, we can see the count of correctly predicted records and misclassifications. So these diagonal boxes are the correctly predicted records. In this graph, on x-axis I have predicted class, and on y-axis I have true class. Close this graph, and in the text area we can see the performance metrics of random forest algorithm. Now click on Sentiment Prediction on Test Data button. A dialog box opens. Select the test data and click on Open. So here we can see tweet, and after arrow symbol we can see predicted people's reaction from that tweet as positive, negative or neutral. We can scroll down to see the prediction for all the tweets. Now click on Sentiments Comparison Graph button. So in this graph, on x-axis I have sentiments types, and on y-axis I have count of the sentiment type. We can see there are more number of positive reactions. Close this graph, and the conclusion here is this project successfully applied random forest to evaluate opinions expressed on Twitter about COVID-19 vaccines. We successfully predicted the sentiments with new test data by training on a dataset of related tweets. By visualizing sentiments through comparison graphs, the public's opinion could be better understood, revealing fears, support, and concerns. This method offers a practical tool for assessing and comprehending various points of view on vaccinations in the context of the pandemic.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.